All right, today we are diving into one of the most mind-bending technologies out there, generative AI. We're going to cut through all the hype and really get under the hood to see how a machine goes from just, crunching numbers to actually creating something totally new.
Okay, so look at these boots. The detail, the lighting, the way the material looks, they seem 100% real. Yeah, but here's the thing. They're not. A machine completely dreamed this up and built the image from nothing. This isn't just running code. This is a new kind of creation.
And that is the big question we're tackling in this explainer. How do you go from a bunch of ones and zeros to a machine that can dream up a pair of boots or write a poem or even compose music? I mean, it feels like pure magic, right? But it's not magic. It's just a really fascinating process.
Okay, so to get our heads around this whole creation thing, we've got to start with language. Because think about it. Most of the time, it all starts with a simple text prompt, right? The way an AI learns to understand and use language is really the engine driving almost everything we're seeing. So here's the key thing to remember. For all their mind-blown complexity, these huge language models are basically super smart prediction machines. Their main job, their fundamental task, is to look at a bunch of words and then make a really good guess about what word should come next.
Let me give you a classic example. If we feed a model the phrase, "it was a dark and," it has to figure out what's next. Its brain, if you want to call it that, is just this massive map of how words relate to each other statistically. It learned all this from reading like the entire internet, books, articles, everything.
And you can see how this thing thinks, right? After the word dark, its best guess is and. Okay, add and to the mix. Now its new best guess is storm. Add that, and the next most likely piece, or token, might be the letter Y to start the word stormy. It's just this constant chain reaction of guessing the next most likely thing one tiny piece at a time. Now the simplest way it does this is with a strategy called greedy decoding. And it's pretty simple. At every single step, it just grabs the one word that has the highest probability of coming next. Now, sometimes this can make the text kind of repetitive or weird, but it's the basic building block of how this all works. But, just picking the next most likely word can get messy. To make it all actually make sense, the model needs to understand context. And that's where this total game-changing technology called the Transformer architecture comes into play. It's what lets the model look at all the words in a sentence at once and figure out which ones are most important. It's the secret sauce that gives these models their incredible grasp of language.
Okay, so predicting words, that kind of makes sense. But how in the world does an AI create a whole image out of thin air? Well, the process is totally different. And honestly, it's built on this kind of backwards but brilliant idea. You learn to create something by first learning how to destroy it.
This is what we call a diffusion model. And it's wild. Instead of giving the AI a blank canvas and teaching it to paint, we do the exact opposite. We take millions of real pictures and then we systematically wreck them by adding more and more digital noise until they're nothing but static. And the AI's entire job is just to learn how to undo that damage perfectly.
So this is what the AI learns from. It sees millions of images that look just like this corrupted, noisy mess. And it's constantly being asked, okay, given this mess, what did the slightly less messy version look like? And by solving this puzzle, like billions and billions of times, it starts to get this incredibly deep understanding of what a normal, clean image is supposed to look like. Right, so once the AI is a master at cleaning up noise, that's when the real magic happens. You can literally just give it a screen full of random static, total noise, and tell it, go for it. It uses everything it learned, but in reverse, finding a picture inside that randomness and slowly pulling it out, until you get something like those boots we saw. So it's pretty amazing it learned how to create by mastering the art of fixing things.
But of course, a model that just spits out random pictures isn't all that useful, is it? We need a way to control it, to tell it what to create. And this is where we link that language stuff back to the world of images. And the trick here is to connect our language world back to the image world. During training, it's not just shown a picture of a boot. It's shown the picture and a text label that says a boot. So the AI learns to connect the visual patterns of a boot with the actual words. That way, later on, when you type in a boot, it knows exactly what visual idea it needs to start building. In this whole process, where you take a big, pre-trained model and teach it a new trick, that's called fine-tuning. We're not building the whole thing from the ground up. That would take forever and cost a fortune. Instead, we're taking this general-purpose model and just tweaking it a little bit so it can follow our specific instructions. And what's just nuts is how efficient this whole thing is now. With new techniques like PEFT, that's parameter efficient fine-tuning, you can do something really clever. Basically, we can lock down the huge original model and just train this tiny new layer on top of it. I mean, look at that number. You only need to change less than 0.5% of the model to completely customize it. That's a huge deal. It makes this technology so much more accessible.
So, okay, we've got these incredible creative tools, but there's a catch. Because they learn from us, from all the data we create, they also learn our flaws, our blind spots, our biases. And that's a really serious challenge we have to face.
Which leads to a really important question. Look, the AI isn't thinking for itself. It's basically just a mirror. It's reflecting the patterns it sees in all the text and images we've been feeding it for years. So, what does that reflection actually show us?
I mean, check out this example from the source material. It's pretty shocking. When a model was asked to complete the sentence, "This man works as a," it suggested things like farmer and carpenter. For "This woman works as a," it came up with maid and nurse. And the thing is, the model isn't evil. It's just spitting back the statistical biases that it found in the data we gave it.
And when you see stuff like this, it becomes crystal clear why transparency is such a big deal. If we can't look at the data a model was trained on, it becomes almost impossible to figure out what biases it has, let alone how to fix them.
And that's why we need to talk about the difference between something being truly open source and what a lot of companies call open access. See, a lot of places will release the code and the model weights. That's the finished product. But to be truly open source, you'd also have to share the training data. And that's the one piece that's almost always kept under lock and key.
So this all leaves us with a really tough final question. We're literally building machines that hold up a mirror to our own society, showing us the good, the bad, and the ugly. And as this tech gets woven into everything we do, figuring out who's responsible for what it learns and for what it creates, well, that's maybe one of the most important conversations we need to be having right now.